I am Hao Jianzhong from Linaro. Today, I will start a topic about the evolution on NFS. Let's see the figure first. Here, three storage era described. The first one is directly attached storage. That means the storage device is attached. It's already on. It's on. It's on for the Zoom. It's on for the Zoom and the webcast. Okay, I can speak louder. For the storage attached device, for the direct attached storage, that means storage device attached to the local host. So it could provide only limited storage expansion. For the network storage era, that the storage device shared data over the network. So, but we can see that it's in the older time, and now the requirement is about the scale out storage. That means the storage should grow much more larger, and we should expect that the network sharing should perform better. And we also listed some versions of NFS. In the V2, it's only about the limited file sharing, and the file size is only limited for the 2 gigabytes. And it's based on the synchronized write, that is data write to the disk first, then response to the client. For the V3, it's improved as the asynchronous write. That means the server could respond to the client immediately and flash data later. For both V2 and V3 are for the small-scale network system. And in the V4, it's changed. Some new features are added. Especially there are the stateful protocol. That means the server could track the client behaviors, and the client doesn't need to communicate with server frequently. And also compound request is supported. For example, in the V3 mode, in the NFS V3, if we want to read a file, we needed to send several data requests to the server. For example, open, read, and close. When so the network traffic is huge. When the compounder requests support, so the network traffic could be reduced to 30%. And in the V4.1, it added the parallel the behavior. For the parallel, I will expand in the later slides. And here, for the NFS V2 is new, and it added some new features, and I will explain later. Okay, here is talk about the limitation on the legacy NFS. For the legacy NFS, actually it means V2 and V3. We can see that there's only one NFS server that communicates with storage systems. And the I/O stream and the control stream all go through the NFS server. So it's the bottleneck of the whole systems. And in the NFS v4.1, the parallel NFS, the limitation is removed. Okay, so let's see the involving requirements on the network system. Because the industry is always changing, for the economic trends, we always need the cheap and faster the computing clusters and the network. We also need the cost-effective storage systems, whatever is based on the flash or flash and SATA. And we also expect the improvement on performance, because the NFS v3, there's a bottleneck the bottleneck. So we want to resolve this feature and resolve this issue. And we have the increased demands of the computer parallelism and the consequent data parallelism. And because with the current usage model, the data analysis creates more data, such as the AI. We will create more and more data, and the data size is growing exponentially. And all of this that should be all of this should be meted by the NFS v4.1 and the v4.2. Okay, here I will introduce some main feature from the NFS v4.2. Let's see the figure first. For the so let us use an example. For example, if I have a directory that the quota is 2 gigabyte. So from the current view, that some of the space is a free space, and others are occupied. They are we can see the color with purple. Although some data are deleted, they are deleted from the file systems, but the data is still occupied on the storage because some reasons. So it's also the reason that you can recover data later, because the data is not deleted at all. This is the current view, but it also but it also with a lot of space. For the thing provide the view that we can call it as a lazy allocation. So for this, the free space, for the free space, it is not allocated the blocks. So it will only allocate the block when you use it. But the deleted file is also marked unused. You cannot use it directly. So this, for the VM usage case, it also wastes a lot of storage device. And it also may provide, it also have the risk of the oversetting storage. And for the third one, it's the hole punched. That means we only the storage, the sparse storage saving. That means we only storage the actual data and skip the empty blocks. So whatever is the space that are not allocated, or whatever it's the blocks that are already deleted, the blocks are not occupied anymore. So from this view, that the sparse file support can improve the utilization of the storage saving. So it's very critical for the VM data stores. It could avoid the waste the SSD space on the empty virtual blocks, and it allocates storage only as needed, not upfront. And so it has some. It should be supported both on the client and the server. So it should meet the consistency. So ensures client and server agree on the allocated space. Okay, let's see some other features from the NFS v4.2. A labeled NFS that is about to support the SE Linux, for example. We can have some label such as top secret, as a less secret. So maybe a user have only the less secret the label when he wants to access the other files that are marked with confidential. So it cannot access the file, although the administrator gives him the POSIX access, but he cannot access the SE Linux. The security has the high priority. And for the ID advice feature is about the client could inform the firm that inform the server that for the next I/O pattern, what's the behavior of the next I/O pattern. For example, it could be the sequential, it could be the random. So with this hint, the server could understand and understand the behavior, so it can improve the performance on the I/O. And for the server-side copy, is also bring out by the NFS v4.2. Here use one word, use one sentence that remove the one leg of the copy. So let me explain it. For the copy, if you want to copy the data from one storage device to another one, for a typical view is that you should copy the data from the storage device to the client first, and then you copy the data back to the target, the storage device. So there are 2 steps. So with the server-side copy, that we only need one step. We just the client also the client only requests the server to copy, and it will copy automatically. So it can avoid the data copy the back and forth over the network. So it saves the network traffic. So it also has the implementation is not fixed. There are 2 types. One is Chrome and the other is copy. So it's depend on the vendor in implementation. And it's also related about the security. So we also should realize that the security model should be updated. It's rated to some standards. Okay, and here is the more important feature from the NFS v4.2 is the flex files. So before I talk about this feature, so let me explain an idea about the files stripping. For example, if you have a large file that is stored on the device A, and you have a lot of clients want to access this large file, and so if you have n clients, each client can only have one nth the I/O bandwidth of the device. So when even more clients join the compete, and you can get less bandwidth, the performance is downgraded a lot. So the file stripping feature means that we can split the large file into a lot of pieces, and each piece on one storage device. So even we have a lot of requests from different clients, they can access to the different storage device. But it also means that this feature, the new feature, also means that the new system, the new hardware, with the flex file feature, NFS can implement this on the metadata server. So the metadata server master the key is all based on the software. So the customer doesn't need to upgrade their storage systems. And for the clustered file systems such as Ceph, they also provide some parallelism capabilities, but they are not standard. As we know that NFS is a standard, so we can implement we can make those clustered file systems support the flex file, support the PNFS. Then we can have a PNFS client to access the clustered file systems. So we use standard NFS client to access as a distributed file systems. Okay, for this, it also mentioned it explained that there are 4 layouts of the NFS The layout are file, block, and OSD. They are all defined in the NFS v4. NFS v4, yes, and the flex file is defined in the NFS v4.2. And the SCSI PNFS layout, it could extend the block volume support for tighter SCSI storage integration. Okay, so again, so let's explain why we use PNFS. So PNFS can combine the bandwidth from the multiple servers. As we talked that in the NFS v3, the I/O flow and the control flow are combined, and in the NFS v4.1, the I/O flow and the storage flow are separated, so the client can access the meta server for the necessary information. For example, where the file stores in which device, then he can access the device directly. So from this view, it implements the parallelism on the file sharing. So this is the flow about the PNFS or client. The client read or write a file, and the server grants permission. And because the file may be stripped, so it also needed to tell the client which device the client should access. And at last, the client access the data servers directly by parallel. And it removes the I/O bottleneck. And from a few view, one is there's maybe not limit only one. There's in NFS v3 there's only one NFS server, and in the NFS v4.1 you can have more servers. And because it has supported the file stripping, it improves the data. It improves the performance of loading the large file performance, and the data and the clients are load balanced. Okay, here we use some example about the NFS. So let me introduce the Hammerspace first. Hammerspace is a company that they contributed the flex file layout, and they contributed a lot of patches into the Linux kernel. And in their implementation, they do the test on the cloud system. That means that their PMF system is much easier to be deployed, and their networking is based on the Ethernet. So that means it could be very cheap. And you can see other vendors such as DDN, HPE, all of them are based on the infinite band. That means expensive network. And they also use the LIS25. That means expensive. And it's dedicated HPC systems. For this test, that is the ISNet. This test is based on the accessing small files. For example, as we know that the ImageNet system, you have a lot of small files. Each file may be 100 kilobyte size, and each file is a picture that for the AI systems you are training data based on these files. So so for the file systems, if the I/O expansion So we want to check. We want to know which network sharing system, which system can provide the better performance. So we use the simulated GPU. We can see that for the one client that is is 6 storage server for the they can simulate the 8 numbers of accelerators, but for the 5 clients we can provide more and more number of accelerators. If we move to the throughput, we can see that the throughput is improved. The throughput scale improved at a scale, and so this is the figure that is better to understand. For example, the DDN, we can see the DDN that the result is 512 accelerators for 32 clients, but for the Hammerspace solution, they can provide the clients and the storage nodes at scale. And actually, in the real case, as we all know, Meta developed the Llama 2 and the Llama 3 in their lab environment. Their network system is built by the Meta and Hammerspace. So this test result, so we can think that it is demonstrated in the real industry. And at the last, we can see the roadmap of the Hammerspace, and they have a lot of patch set on the NFS client. So now we already know that the parallel NFS 4.2 flex files and connect are already merged in the Linux kernel. For the new ones, for example, the local I/O, they can bypass the network stack in the local, and for other features are coming. That's all. Any questions?